Okay, welcome back to Calculus 2. So we are looking at problem number 2C, I think, pretest 3. So we're looking at does the series 1 over n to the 3 halves plus 1 converge or diverge, and why? Again, I don't want you to just flip a coin and tell me. I need you to show me why this is going to happen. So the first thing I'm thinking about is like, well, maybe p-test. Like, well, p-test, except for p-test has to work with like, if it was just this, 1 over n 3 halves, we would definitely have a convergence because this thing, by p-test converges. So converges by p-test. However, that's not the series we have. We have n to the 3 halves plus 1. This might be different. So what we have to do is we have to do the comparison test. So we're going to say, is 1 over n 3 plus 1, is this always less than 1 over 3 halves? Okay. So what we're going to do for that is we're going to say, well, let's go ahead and do it the other way around. So can I say that n to the 3 halves plus 1 is greater than n to the 3 halves? I think it's pretty obvious that we can say this. I'm also going to make a note here that n to the 3 halves is always going to be greater than 0. And that's going to be important because we're going to divide by some stuff. And if I'm going to multiply or divide with an inequality, if it's negative, I would have to switch the sign. But since we know that n to the 3 halves, n is always positive, n to the 3 halves is always going to be positive, these are always going to be positive numbers. What I'm going to do is I'm going to multiply both sides by 1 over n to the 3 halves times n to the 3 halves plus 1, both sides for this. N to the 3 halves times n to the 3 halves plus 1. Okay, we're going to cancel some stuff here. So we have our inequality. We did not have to swap the sign. So we're going to be able to say this is going to cancel on this side. And then on the left side, that's going to cancel. So we're going to have 1 over n to the 3 halves is always going to be greater than 1 over n to the 3 halves plus 1. Okay, usually in American education, we usually write it so we don't say that n to the 3 halves is greater than n to the 3 halves plus 1. You could. Usually they set it up so it's on the left. So the thing I'm looking for is 1 over n to the 3 halves plus 1. Less than, right? The alligator's mouth always eats the bigger one. It doesn't, just because I swap I wrote which one on the left or the right, the bigger one is still the bigger one. The alligator is still hungry. Okay. And I know I go back to second grade when I'm dealing with inequalities, but so be it. Okay. Now we can say by comparison. So since n to the 3 halves, 1 over n to the 3 halves converges by p-test, okay, and 1 over n to the 3 halves plus 1 is always smaller than this thing that converges, okay, then we can conclude that n to the 3 halves plus 1, whatever that, converges by comparison with n over 1 over n to the 3 halves, which converges by p-test. Okay. Okay, so that's kind of what we're dealing with all of this stuff. I know it's a lot to write, it's a lot to kind of figure out, but the whole point of this part of the chapter, of this part of the course, is to kind of like force you to show your work. Because you can just say converge, and yeah, why flip the coin to figure it out? Like that's not going to be good enough. Okay, you're going to have to justify what's going on with this thing. And depending on who's checking your work, how much do you have to justify it? So I'm you didn't have to quite go through all of this. You could make a little bit better than that. But I do want you to like go through the steps to say, okay, if you're going to do comparison, whatever you're comparing it to, if you're showing that whatever you're comparing it to converges, you got to show that the value that you're comparing it to is actually less than. Because if it's greater than, it's like, well, I don't know if this converges and it's bigger. Like, I don't know if it's going to converge or not. So you got to be really careful with this stuff and just try to make sure that that's going to be able to work out for what it's going to do for you. Okay. Thank you very much for watching my video. I'll see you in the next one. Take care until then.